Hi, in this video, I wanted to show you a dual-purpose spot welder that I built recently. Yes, it is based on a microwave oven transformer like many people have done before, but unlike most of the videos you probably have seen on YouTube, this one I have here has some built-in safety features and also provides more functionality. You see, most of the microwave oven transformer-based DIY spot welders use a momentary switch to switch the primary side of AC directly. This is actually quite dangerous. The reason is that when you are operating, your hands are typically next to the momentary switch, and if the insulation is not sufficient, you can accidentally touch the live wire and cause electrocution. And the primary concern of just using a momentary switch to switch the primary AC is that because of the microwave oven transformer can supply a lot of current, there's a lot of current flowing through the primary and secondary, especially when you have the secondary shorted. The current spike and inductive nature of the winding can sometimes produce a huge arc, and that could either damage your insulation of your switch, or the current simply just too high for the switch to handle. In fact, sometimes the primary side current can reach north of 30 amps momentarily. So that is clearly more than enough for most of the momentary switch to handle. So in order to make the design safer, we basically really needed to isolate the switch on the primary to your trigger button. So here let's take a look at the design I have. So here's the circuit that I used for the spot welder. And as you can see, it's really not complicated. It has this portion is a 555 timer based single shot circuit, which generates a single pulse that triggers the secondary triac, which in turn turns the primary on or off, and so that we can have a controlled width of the welding duration. So the 555 timer circuit here, as you can see, R4 and R2, they form this charging resistor, charges this C3 capacitor. And the triggering point is, so basically this determines the time constants of the output pulse. And to trigger that, we can simply just ground pin 2, okay? So the reason I added the C2 and R1 here, I'll explain right now. And so these three are actually forms the pulse to drive the trigger. Because if you ground the pin directly, the pin 2, what happens is the pin 3 will immediately turn high. And so the minimum duration of the pulse output would be affected by how fast you can release your finger, basically. So here with this RC circuit, this RC constant is sufficiently short so that when you push the trigger, the triggering pulse is very narrow, and so the output signal is determined entirely by this R2, R4, and C3 RC constants, rather than how long you have pressed the button. So, and moving to the right, so the output basically, as we mentioned earlier, it drives the this LED inside this optocoupler module, and this MOC3061 is a triac driver that basically essentially is just a optocoupler. So when this triac is triggered, we have a couple of components here. So the main components here are the R8 and the C4. So this actually forms a snubber network to prevent the transient on the primary side. And then we have the couple of resistors here. Basically provides the triggering the gate voltage. That's actually all there is to it, to this circuit. And I just lifted this welder a little bit. As you can see here, it's probably a little difficult to see, but here's a triac, and here's the optocoupler, and here's our 555 timer. And let me just set the front to focus. And the knob here, basically, we can fine tune the pulse duration of this welder. So now if you look at the construction of this welder, everything is actually constructed with the material that I have off my hand. For example, here is a backplate of an LCD display, and these supports are actually from some of the server rack mount parts. So basically I just grabbed what I have to build this. Now one feature of this spot welder, probably you're wondering what the heck this thing is here. Well, so basically most of the welder you see nowadays can only do one type of weld. For example, I have here, you have this two opposing electrode, and where it's very convenient, which is very convenient for welding two pieces of sheet metal together that way. But you cannot use that to do battery tab welding. So basically what I did is I built a separate set of electrode, and as you can see here, it has two sharp tips here, and then again we have a same momentary switch to trigger this. And because we are actually welding battery, right? So battery tab, and so these two electrodes are on the same side. And also, because of the battery welding typically requires slightly less current and very short duration. So you can see here the wire is actually, the gauge is significantly thinner than the primary. So that's what this is, which I will demonstrate in a little bit. So, and also I just built this holder, so when you're not using that, you can put it on this holder. And as we just shown earlier, so the two momentary switches, one is for the main switch here, and the other one is for the switch on this smaller electrode. And let me just show you the rest of the construction here. So this thing is actually quite heavy. And on this side, basically, this is where AC goes in, and the transformer here, as you can see, we just had this, I think it is a gauge 4 wire I had. And actually, I originally planned to use this wire for my high current electric load project. But it turned out this is actually too thick, and I couldn't really get it to hook up to my alligator clip. So I actually just abandoned that. So now, actually this is quite handy. I put 3 wands here, and that's actually 3 volts the output is when there's no load. So that is the transformer side, and then everything else just purely mechanical, except for the circuitry that I just described earlier. So now let's demonstrate, and I know you guys are all dying to see what this can do. So basically, for what we're going to do, I'm going to have 2 pieces of thin metal piece, and we're going to use this main welder to weld it together. Before I forget, so the only thing I really had to buy for this welder is really this welding tip. Actually, these tips are quite nice. They're really durable compared to the simple copper one that you know, some people make themselves. But these ones I bought on eBay, and if you just Google or you just search for spot welder tips, you will see these. These have different diameters on the other end. So I bought this M5 one, and with a 3/8 of a inch welding tip, which is I think the smallest one, which is still a little bit too big for what I'm using, but that nevertheless was the smallest one you can get. And so the crimp here I bought, this lug is actually for automobile use, and they do have the holes matching this M5 ones, but the one I bought actually is a little bit too big because I didn't check carefully. But nevertheless, it works out to be okay. So now, for the demonstration, right now I just hooked up the power, and so let me be quiet and I'll press this momentary switch. And what you will hear, you probably will hear, I don't know if you can, the humming of the transformer. But right now I set this timing to the shortest. So let me just give it a try here. So now we're not connecting anything here. So you can hear a really short burst, and if I turn it all the way up, you'll hear it lasting for about 7 seconds or something like that. And you can hear it humming. So that essentially is what that circuit is doing. So okay, so now let's try with this 2 pieces of metal, and I actually, this is pretty thick. This is not your battery tab. I just cut it from I think it's some kind of insulation shield or something. So it's I don't know if it's aluminum or steel. We'll see how well it works. So now most people sometimes, like when you see this on YouTube, you will see that they actually let it heat up quite a bit. Everything is glowing red. You really don't need to do that. So basically, for all this is a very short pulse of a high current through, and it will melt the metal significantly to have these 2 welded together. So right now, let's try the lowest current to see if we can weld them together. So that's actually done. So let's see, as you can see here. So let's zoom it in a little bit. Okay, here we go. So as you can see, the single dot is where the current went through, and now they're actually welded together, and I can't really break it apart, which is exactly what you want. So now, of course, we can make it longer, and the problem of increase the duration if you don't need it is that it heats up the metal significantly, especially when you are welding battery. You really don't want that to happen, because you don't want to heat up the metal. So let's try it again. So this time I'm going to do it here, and we're going to use a slightly longer pulse, and you will see the result here. So now, and you can see here, this is significantly longer. So the second welding spot, you can see there's significant melting of the metal around the spot, whereas the first one is really small and clean. So anyway, so that's the main welding part. So now let's take a look at the battery tab welder portion. So again, this set of electrode is in parallel with the main set of electrode, and the only difference is that the wiring is slightly thinner because we don't need as much current to weld the battery tabs. Now that said, that depends on how thick your battery tab those connectors are, and right now I don't have the actual those thin nickel strips, but let's see if we can use the same material, and we might not be able to, but we will find out. So now I'm going to press it down, and I'm going to yeah, this timing is probably okay. So no, it doesn't seem like we made much dent here. So let's try again. I'm not sure if okay, here. I'm not sure if you can see. It's actually the tip is heating up because it's really narrow. So so now I did it twice, and we can see that we were able to weld it actually pretty tightly. So again, because we are doing that, the pulse is very short duration, so these tabs are not heat up significantly, so which is very good for battery welding. So anyway, so this is the little project I did recently, and for the circuit diagrams, and I will put it up on my website, and you can take a look and can build your own. And I just want to show you why it is not a good idea to switch the primary side directly. I have here the setup is that I get a clamp meter to measure the input current. So I had it on one of the input lines to the mains. And my plan is here to basically press this down to short the secondary and press this button. So now I'm going to adjust this to be a little bit higher. So this is actually so that the duration is a little longer. You can actually see the current flowing through the meter. So now let me move my tripod here so we can see the clamp meter here. Okay, so right now we're reading, give or take, really nothing, but let's just zero it. So now we're 0, and I measure the AC current here. So let me press that down. Now watch the meter. So as you can see, we are actually drawing about 28 amps on the primary. So even though this microwave transformer is rated only for 1,300 watts, the current actually flowing through is almost double that. So that's why you don't want to use this small 15 amp rated switch to switch to the primary. And on top of that, as I mentioned earlier, if there's any arcing inside, it could literally destroy this momentary switch and possibly exposing the conducting element and electrocute you. So that's why it is more than important to build a safe spot welding circuit like the one I used here. Anyway, I hope you enjoyed the video. If you did enjoy the video, please give it a big thumbs up. I will catch up with you next time.